This is chapter 1.6. This is our first part in which we're going to look at some additional equations and some applications of those equations. So in this chapter, the two objectives that we're going to look at in part 1 is solving polynomial equations, and our second objective is to solve rational equations. Objective 1, solving polynomial equations. In this equation, we have four terms, and we have an equation which is of a third degree. So here in example 1, we have 8x cubed plus 4x squared minus 50x minus 25 is equal to 0. Whenever we have even terms, we can try using a procedure called grouping. So we're going to group the first two terms, the 8x cubed plus 4x squared, and we're going to group the last two terms, the 50x plus 25. Notice I've taken out a minus when I put the parentheses in. Now I put the minus outside, so if I distributed, it would be the minus sign. And so this equals 0. So in this case, I can take out a 4x squared from the first parentheses term, and I get 4x squared parentheses 2x plus 1. In the second parentheses terms, I can take out a 25, and when I do that, I get 2x plus 1. Notice that I have similar factors in two terms, which is 2x plus 1. If I can take those two terms out, I'm left with 4x squared minus 25 times 2x plus 1 is equal to 0. And I notice that I have a perfect square of 4x squared minus 25, and that perfect square is the difference of squares, which is 2x minus 5 times 2x plus 5, and of course we have the last term 2x plus 1. So now we can set the factors equal to 0. 2x minus 5 equals 0, 2x plus 5 equals 0, and 2x plus 1 equals 0. When we solve for x for all three, we get the solution for x to be 5 halves, minus 5 halves, and 1 half. So in practice skill number 1, we have a four-termed equation. The four-termed equation, we have a polynomial of third degree, 25y cubed plus 100y squared minus y minus 4 equals 0. And we note with four terms, grouping might work. So we're going to group the first two terms, 25y cubed plus 100y squared, and we're going to group the last two terms, y plus 4. Notice that when we take the negative out of the terms and put parentheses around them, it becomes a y plus 4. So now in the first terms, we can take out a 25y squared, and we're left with y plus 4, parentheses closed. In the last term, we automatically have parentheses y minus 4. Now when we take the y plus 4 out of the two terms, we're left with a perfect square, 25y squared minus 1 times y plus 4 is equal to 0. Now this perfect square can be broken up into two pieces. 5y minus 1 times 5y plus 1 times, of course, y plus 4 is equal to 0. We can set each one of those factors equal to 0. 5y minus 1 equals 0, 5y plus 1 equals 0, and y plus 4 equals 0. And when we solve for y, we get the solution 1/5, negative 1/5, minus 4. So in example 2, we have a difference of cubes where it's 8x cubed minus 1 is equal to 0. So you recall that the difference of cubes is a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So we let a equals 2x and b is equal to 1. And so now we have 2x minus 1 times 4x squared plus 2x plus 1 is equal to 0. Now we have 2x minus 1 equals 0, or 4x squared plus 2x squared plus 1 is equal to 0. X is equal to plus 1/2. So that comes from this part of the formula, or this factor. Now we notice that we have a quadratic. 4x squared plus 2x plus 1 is quadratic. So we can use the quadratic formula, and when we do that we have a minus 2 plus or minus the square root of 4. When we square 2 we will get 4 minus 4 times 1 and divided by 2 over 4. So we get a minus 2 plus or minus the square root of 4 minus 16, which is a minus 2 plus or minus the square root of minus 12 over 8. So minus 2 plus or minus 2 divided by the square root of 3 over 8. And so now we can take a 2 out from both terms. We get a minus 1 plus or minus the square root of 3i over 4. And so those are our solutions. We have 3 solutions here. And so that's what works for this particular problem. So in practice skill number 2, we're going to first use the 0 principle. We do not divide by w because we're trying to solve for w. So we have w to the 4th minus 27w is equal to 0. We take a w out, and we have a w times w cubed minus 27. There is a difference of cubes, and so in this particular case we have w times w minus 3 times w squared plus 3w plus 9 is equal to 0, and this gives us the following factors. W is equal to 0, w is equal to w minus 3 is equal to 0, and w squared plus 3w plus 9 is equal to 0. Now w squared plus 3w plus 9 is equal to 0 is quadratic. And so now we have w squared, we can use the quadratic formula, w squared plus 3w is equal to a minus 9, w squared plus 3w, and now we take the completing the square, we take half of 3, and we square it, we get 9/4, and we add 9/4 to both sides, and when we do that we get w plus 3/2 squared is equal to a negative 27/4, So we have w plus 3/2 is equal to plus or minus the square root of a negative 27/4. This now is w minus 3/2 plus or minus the square root of a negative 27/2. And now we have w is equal to a minus 3 plus or minus 3 square root of 3I over 2. And so our solutions are, we have 0, a plus 3, and then if I took 3/2 out, we get 3/2 times a negative 1 plus or minus square root of 3 times I. So now we're going to look at objective 2, which is solving rational equations. So the principle in solving rational equations, as we stated in previous sections, is to find the common denominator first and then multiply both sides by the common denominator. So in this particular case, the common denominator is x minus 1 times x plus 1. And notice that if we get a solution of x equals 1 or x equals minus 1, they could not be plugged back into the equation because we would be then dividing by 0. So when we multiply through by the common denominator of this equation, we end up with the following result. X plus 1 minus 2 times x minus 1 is equal to 2 times x plus 1. Notice that when we multiply through by the common denominator, the fraction goes away. Now we want to start combining like terms. So here we have x plus 1 times 2x plus 2, we use the distributive property, is equal to 2x plus 2x minus 2. So we end up on the left-hand side of 3 minus x is equal to 2x minus 2. We end up with 5 is equal to 3x, and so in this particular case, x is equal to 3/5. We certainly want to check our answer, but this one does work, and it's up to you to pause and see if it does work. And so we'll go to our next example. So in this example, again, we're going to do the two major strategies to solve the problem. One is find the common denominator, and in this case, the common denominator is x plus 3 times x minus 1. And we're going to multiply that common denominator on both sides of the equation. When we do that, we of course eliminate the fraction. So the first term is going to end up being 2 times x minus 1 when we multiply the common denominator through. Why is that? Because the x plus 3's cancel. When we multiply the common denominator on to the second term, which is 2 over x squared plus 2x minus 3, we just get minus 2. And then on the left-hand side, when we multiply the common denominator 3 through, the x minus 1's cancel, so we end up with 3 times x plus 3. So again, we're going to distribute. So the 2 distributes on the left-hand side. We get 2x minus 2 minus 2. And on the left-hand side, we get, on the left-hand side over here, we get 3x squared plus 9x. So now we see that we have a potential polynomial of second degree, which is a quadratic. So we'll move everything over to the left-hand side of the equation and set it equal to 0. We'll use the 0 principle. And so 0 is equal to 3x squared plus 7x plus 4. And so guess what? We'll try to factor first. And this thing is factorable. It's 3x plus 4 times x plus 1. And we see that once we set those factors to 0, we get the solution of x is equal to a negative 3/4 and x is equal to a minus 1. Both of those solutions work. Notice that in this case, if x had been 1 or x had been minus 3, we would have had a problem, but we don't have a problem in this case. So in practice skill number 3, we're going to solve the equation 3x squared divided by 5 minus x minus 5 is equal to 2 divided by x plus 1 plus 2x squared plus 40 divided by x squared minus 4x minus 5. You will notice that the common denominator here is going to be a minus 5 times x plus 1. If we multiply both sides of the equation by that common denominator, you will see on the left-hand side we end up with 3x times x plus 1. On the right-hand side, we have 2 times x minus 5 plus 2x squared plus 40. Notice that the fractions go away. Well, now we want to do the distributive properties. So when we distribute the 3x times x, we get 3x squared. 3x times 1 is 3x on the left-hand side. On the right-hand side, we see that we have 2x minus 10 plus 2x squared plus 40. Again, we're going to see that we have a polynomial of degree 2, so that's a quadratic, so we're going to use the zero principle for sure. So we're going to move everything over to the right, or the left-hand side this time. So when we combine like terms, we end up with x squared plus x minus 30 is equal to 0. We see that that is factorable into x plus 6, x minus 5 is equal to 0. And we end up with x equals 5 and x equals minus 6. But wait, 5 doesn't work. Why? Because when we plug it back into the original equation, 5 minus 5 on the left-hand side is going to be what? 0. So we can't divide by 0, so the only solution here is x is equal to minus 6. We call this 5 an extraneous solution. So in our application problem, skill practice number 4, a fishing boat can travel 60 kilometers with a 2.5 kilometer per hour current in 2 hours less time than it can travel 60 kilometers against the current. Determine the speed of the fishing boat in still water. So we are going to set up a table for information that's going to help us use our strategy. Remember, the strategy here is distance is equal to rate times time. But we can also, if we know the distance and we know the time, or if we know the rate, we can always do distance divided by rate is equal to time. And so we're going to use that factor here in just a second. So we have upstream and downstream, and we have distance for both upstream and downstream is 60 kilometers. We have the time, so upstream is going to take 2 hours longer than it does downstream. We always want to put time as positive in any fashion, so we don't get a paradox. So t minus 2 doesn't work so well as t plus 2. Then the rate, we have upstream, we're going against the current, so it's going to be x is our rate minus 2.5 kilometers per hour. And downstream, it's going to be the rate of x plus 2.5 kilometers per hour. So you'll notice that in this particular case we have two different equations. We have 60 is equal to 2 plus 2, t plus 2 times x minus 2.5. That's directly related to upstream. Well, in downstream, since we're looking at we have two variables with two unknowns, and so the idea here is solve for one variable. So the downstream variable will solve for t, since that seems to be the easiest thing to do. T is equal to 60 divided by x plus 2.5. Now we're going to plug the t into t in the first equation, and when we do that we get this equation here. 60 is equal to 60 over x minus plus 2.5 plus 2 times x minus 2.5. Then we can work with the parentheses first. So when we do that, we get 60 is equal to parentheses 60 plus 2 times x plus 2.5 divided by x plus 2.5. We're just dealing with what's inside the parentheses first, times x minus 2.5. Now we're going to multiply through by x plus 2.5. Well, when we do that, we only have to multiply the x plus 2.5 on the left-hand side because it goes away on the right-hand side. And then we can obviously expand the left-hand side of the equation, which we get 60 times x minus 2.5 plus 2 times x plus 2.5 times x minus 2.5. We just distributed the x 0.25 to both of these terms after we multiplied through by x plus 2.5. Now, as we expand this, we get 60x plus 150 is equal to 60x plus 150 plus 2 times x squared minus 6.25. It's the difference of squares, and that's what we did here. And so now we're going to combine like terms. It turns out that the 60x's cancel, and the 150, a negative 150 goes over, and we get 300 is equal to 2 times the difference of squares, which is 2 squared, x squared minus 6.25. Now we divide by 2. We get 150 is equal to x squared minus 6.25. We add 6.25 to both sides of the equation, and we get x squared is equal to 156.25. So x, take the square root, and it's going to be the positive square root in this case. We get x is equal to 12.5 kilometers per hour. So that concludes our first part of chapter 1.6. Part 2 will be coming up next. Please review some of these problems that we will also be doing in class.